Marker starting. All right, creating a similar interface for a finite number of threads. We want our thread pool to work in a similar, familiar way, so switching from threads to a thread pool doesn't require large changes to the code that uses our API. Listing 20-12 shows the hypothetical interface for a thread pool struct we want to use instead of thread spawn. So basically, let pool equals thread pool new, and then handing it 4. So we're gonna be able to have 4 threads at any one time. For stream and listener dot incoming, let stream equals stream dot unwrap. So we're doing that right now. Pool dot execute handle connection stream. So I almost want to try creating this a little bit on my own. And get a decent amount into like creating Threadpool just to see what they're planning on doing. So it is a full structure, it looks like. So we can come up here. I'll say struct thread pool, and my guess is we have total threads. This is going to be a unsigned 8 because it only needs to be, it's going to be very small. All right, so we have total threads, and then we're going to want the actual like an array of the threads too. So what if we did, or sorry, not array, a vector of the threads as well. So maybe like the threads. And this will be a vector of what type is thread. I'm actually don't know what the type of thread would be. This is an unknown. I don't want to do like type or anything. That's our main. Is like I'm not actually sure what a thread type is. Or is it not that? Let's take a look. Rust docs thread spawn. When we spawn a thread, is it really just a number that it gives us, like an ID? Thread. Child. No, so it's not a number or anything. It's an actual thing. Okay, so new thread can be configured. Thread type. Threads are represented via the thread type, which you can get in one of two ways. By spawning a new thread using the thread spawn function and calling thread on join handle. By requesting a current thread using the thread current function. Ooh, naming threads. Threads are able to have associated names for identification purposes. By default, spawn threads are unnamed. To specify a name for a thread, build a thread with builder and pass that. Okay, well, so we're probably not going to need to worry about that. I would. So my guess is we could just say thread. Gives me a vector of thread. Okay, so it said thread type, but that's not a real thing. Thread type. Struct standard thread. Oh, does it not exist in this Standard thread. That should make that work better. Right, so now it's never been used. Okay, so total threads, U8, threads is thread. I think that's what I'm gonna stop for right now with that, because now I can say implement Threadpool. And we're gonna have a function new. This is gonna take in a total threads. So total threads is gonna be a what? It's gonna be U8. We're gonna return a thread pool. And what we're going to end up doing is just say thread pool total threads, and then threads is just an empty array for right now. All right, what are you upset about? The trait bound standard thread is not satisfied in thread pool. Standard thread does not have a constant size known at compile time. Oh, so is it in threads here? So it's really upset about that. I told it, hey, it's going to be an unknown vector of these threads. I guess I could do like the boxes, but I'm actually curious about how they're going to solve it. So let's go take a look at theirs. We use Threadpool new to create a new thread pool with a configurable number of threads, in this case 4. Then in the for loop, pool.execute has a similar interface as thread spawn, in that it takes a closure the pool should run for each stream. We need to implement pool.execute, so it takes the closure and gives it to the thread in the pool to run. This code won't yet compile, but we'll try so the compiler can guide us in how to fix it. Okay, so maybe we could just do it this way too. So if I don't have this, so let thread pool equals I guess it would be thread pool new 4. Okay, so we create a new one with 4 of these. It's of course saying no module exists. Okay, so then inside of here, we just have pool.execute and hand it this. So it's going to be thread pool.execute, and then we're going to hand it this closure, which of course this also doesn't exist. So it's gonna, that will error out, but of course this error is out first. So let's go ahead, start, and basically do error-driven development then. Okay, so cargo run. All right, use of undeclared type or module thread pool. So let's just go ahead and create a very basic struct thread pool. That. Okay, next. No function or associated item named new found for type thread pool in the current scope. Okay, so now I can do implement Threadpool function new. We happen to know it's taking a number, so this is going to be the max threads, or I guess I could just say yeah, max threads. Pool size, that's what it is. Pool size. This is a U8. This is a returning a thread pool. And obviously, you can just have it return a thread pool. That. I mean, so technically it's working. Execute. No method named execute found for type thread pool in the current scope. Okay, so function execute. This is going to take in a function. Okay, so this is going to be our callback, or our closure. So I'll just call it closure, and then it's type. Can I do that? Type function. It doesn't look like it's going to return anything at all. So then we have this. The precise format of function family traits type parameters is subject to change. Use parenthetical notation. So function foobar baz instead. The value of the associated type output from the trait standard ops fn once must be specified. So if we do standard ops fn once, standard ops fn once. Okay, so it still doesn't like that. Expected one type argument. Oh, so it wants me to do something like wrap this in prem, so I could show what it's going to return here. But it's not going to return anything. Oh wait, so maybe that's what it wants me to do. Okay, so I wrap this in parentheses. And that like that. Okay. The trait bound standard ops fn once static standard marker size is not satisfied. Standard ops fn once plus static does not have a constant size known at compile time. Help the trait standard marker size is not implemented for static ops fn once plus static. Oh, interesting. So this is, all right, let's see what they do for this one. I know I can like go back and take a look at the function chapter on it, but let's just move forward with it. All right, so building a Threadpool struct using compiler-driven development. Make the changes in listing 20-12 to source main RS, and let's use the compiler errors from cargo check to drive our development. Here's the first error we get, use of undeclared type or module Threadpool. Great, this error tells us we need a Threadpool type or module, so we'll build one now. Our Threadpool implementation will be independent of the kind of work our web server is doing. So let's switch the hello crate from a binary crate to a library crate to hold our Threadpool. Oh, interesting. So we're now putting stuff in the library. After we change to a library crate, we could also use the separate Threadpool library for any work we want to do using the Threadpool, not just for serving web requests. Create a source library that contains the following, which is the simplest definition of a Threadpool struct that we can have for now, which is public struct Threadpool. Okay, so let's go ahead and do this. So they're going to call this a source library, so we need to do that too. So touch source lib.rs, and inside of lib.rs we're going to public struct Threadpool. So pub struct pool. But what's going to be interesting here is that, so in main, instead of this, so we're not going to have any of these. Instead, we're going to now I have to do extern crate name. What did I call this? It's basic web server. Can't find crate for basic web server. Is that not the name of this crate? Okay. Can't find crate for basic web server. Can find crate. Is it built in the right place? LibRS right here. I think that's correct. Let's try compiling and see if we get a better error. Oh, public struct Threadpool expected where, or they have a semicolon after theirs. I didn't think I need one for struct, but I guess I do. Does that fix it here? No, so I guess there is a problem of it. Yeah, now it works. Now it's sort of working. All right, let's continue looking at what they do. Then create a new directory, source bin, and move the binary crate rooted in source main rs into source bin main rs. Okay, that's interesting. So create a new directory, source bin. Do that. Source bin. And move the binary crate rooted in source main rs into source bin main rs. Doing so will make the library crate the primary crate in a hello directory. We can still run the binary in source bin main rs using cargo run. Oh, doing so will make the library crate the primary crate in the hello directory. We can still run the binary. Okay, so after moving to main rs file, edit it to being, okay, interesting. So source bin, and then we want to move source main to source bin. So basically, when I run cargo run, it will find bin and put this in there. That's actually really interesting. I did not know that we could do that. Okay. After moving to main rs file, edit it to bring the library crate in and bring Threadpool into scope by adding the following code to the top of source bin main rs. So use hello Threadpool. Right, I need to do that too. Use basic web server, Threadpool. This code still won't work, but let's check it again to get the next error we need to address. So they're going to get this new, which I believe that we're getting too, but let's also make sure that we're getting that. So cargo run. Yeah, Threadpool new function or item assert not found. This error indicates that next we need to create an associated function named new for Threadpool. We also know that new needs to have one parameter that can accept 4 as an argument and should return a Threadpool instance. Let's implement the simplest new function that will have those characteristics. So I believe if it's the same that I was like thinking of, this can now be, okay, implement Threadpool, and this is going to be a pub function new. We happen to know that it's taking in that U8, so total threads, that's a U8. It's returning a Threadpool, and we're just gonna return Threadpool. And let's run cargo run. Okay, so I mean, it's yelling at us for not actually using this, and no method named execute. So we've managed to pass that one. I mean, so that's exactly what we did. We chose usize. Interesting, they chose usize. We chose usize as the type of the size parameter because we know that a negative number of threads doesn't make any sense. We also know that we'll use this 4 as the number of elements in a collection of threads, which is what the usize type is for, as discussed in the integer type section of chapter 3. Oh, really? So usize is a better choice for this. So let's go ahead and change that. Let's check the code again. So now it's just saying no execute, same as that we got. Now we get a warning and an error. Ignoring the warning for a moment, the error occurs because we don't have an execute method on the thread pool. Recall from the creating a similar interface for a finite number of threads section that we decided our thread pool should have an interface similar to thread spawn. In addition, we'll implement the execute function so it takes the closure it's given and gives it to an idle thread in the pool to run. Okay, so implementing that as well would be, okay, pub function execute. And the thing is, like, this is going to take the closure, which is type fn, but we were running into weird problems where we didn't exactly know how to, like, have it. The closure is not taking anything at all. It's just essentially doing this. And it's not returning anything. So we're just kind of having this for right now. Standard ops function plus static does not have a constant size known at compile time. So I'll be interested to see how they fix that. We'll define the execute method on Threadpool to take a closure as a parameter. Recall from the storing closures using generic parameters and a function trait section in chapter 13 that we can take closures of parameters with 3 different traits: fn, fnmute, and fn_once. We need to decide which kind of closure to use here. We know we'll end up doing something similar to the standard library thread spawn implementation, so we can look at what bounds the signature of thread spawn has on its parameter. The documentation shows us the following: public function spawn ft. Okay, so like the generic function type and another generic type. Then takes in this function, which is that type f, and returns a join handle type t, where f is an fn_once. Oh, so this static here, they need to use this. So T plus send plus static. Interesting, because they're joining those together to be a part of the type. And then the T is send plus static. The F-type parameters is the one we're concerned with here. The T-type parameter is related to the return value, and we're not concerned with that. We can see that spawn uses fn once as the trait bound on f. This is probably what we want as well, because we'll eventually pass the argument we get in execute to spawn. We can be further confident that fn once is the trait we want to use because the thread for running a request will only execute that request closure one time, which matches the once in fn once. The F-type parameter also has the trait bound send and the lifetime bound static, which are useful in our situation. We need send to transfer the closure from one thread to another, and static because we don't know how long the thread will take to execute. Let's create an execute method on Threadpool that will take a generic parameter on type F with these bounds. Okay. So what we can do here is just sort of copy this entire thing. So when our execute, so where f is fn once t, and it's returning a join handle t. I don't actually know if we need the t plus it, because we're not returning anything at all. So it might be simpler. So we have to say like, okay, fn execute, and this is type function. So therefore closure is type F. We're not returning anything, and then right before this happens, we can do a where, or it sounds like everybody else does theirs like here. So where F, okay, so where F is a fn1. Okay, so here's where we do, okay, fn once. That takes in nothing. So what is it returning? If we take a look at what this is, it's Threadpool execute handle connection stream. Handle connection doesn't return anything. So I wonder if that's good enough, or if we need to like say something like we return send plus static. Plus send plus lifetime of static. I wonder if that's what we need to do here. Okay, so that gives us the where in this this execute. If we save this and run it again, let's see what errors we get. Unicorn. Oh, I gave it a tilde, not just a single quote. Cannot find trait send in this scope. Did you mean send with a capital S? Probably I did. Okay, so two unused variables. We're not going to worry about that for right now. No method name execute for type basic web server Threadpool in the current scope. Interesting. This is an associated function, not a method. Oh, it's well, that should work. Found the following associated functions to be used as methods. Functions must have a self param. Oh, okay. So never mind. I forgot that we need a self like that. Hey, and it's running. I mean, I don't think it will actually work, but that's pretty cool. So public f execute, public function execute, generic type f, reference to self, f is type of f, where f is f and once plus send plus lifetime of static. Okay, so that's exactly what we did. We still use the parentheses after fn once because this fn once represents a closure that takes no parameters and doesn't return a value. Just like function definitions, the return type can be omitted from the signature, but even if we have no parameters, we still need the parentheses. Again, this is the simplest implementation of the execute method. It does nothing, but we're trying only to make our code compile. Let's check it again. So we have our 2 warnings, but then we're receiving only warnings now, which means it compiles. But note that if you try cargo run and make a request in a browser, you'll see errors in a browser that we saw at the beginning of the chapter. Our library isn't actually calling the closure past to execute yet. So we can actually do that. I wonder, is there a way to like split down? I don't see an easy one. I guess what I could do is maybe set up tmux or something, which would help with that. Then I could actually call and see the errors here. But until then, I can create a new tab. And here we're going to say, oh, what's the command? It's I want to make a request, an HTTP request. It's not wget, it is I just did it yesterday, I think, or maybe the day before. These are the problems with my brain, forgetting the commands that I use all the time. So I want to actually, you know what? I can do a history and pipe that to grep for localhost. Curl, that's it. Curl localhost 3000. We didn't get an error. We just got recv failure, connection reset by peer, but no error in here. So I mean, I guess that's good. Is there things that we could figure out how to do with this with? Okay, so we have threadpool equals threadpool new, threadpool execute, handle the connection stream. This is all fine. What we probably want to do is actually have this come in here. We're executing, we're passing in the function. Of course, it's not actually doing anything with this. I could throw the thread into this array of thread pools. Okay, so in here, we're gonna have all right, so we're gonna have max threads is I guess it's a usize, and then we're gonna have the actual threads, which is an array of standard ops thread. Okay, so no errors popping up yet. When we create the new, we're going to take in this usize here, and max threads is going to become total threads, and then threads is going to be an empty array. Okay, that should still be fine, and then what we want to do is when we execute, we can just blindly for right now throw it into a thread. Throw it into like this threads vector as soon as we do this. So we have this fn once, we're taking in the closure. So now we want to say threads.push. Maybe it would even be easier to just say, okay, so let thread, so I guess I can just do a thread, equals, we kind of don't need this user standard thread here anymore. We're gonna need this on the other side, aren't we? Use standard thread. Thread. Basically, we would just want to do that, which means that now we can just do thread here like that. Okay, so threads equals thread. Oh, is it not? Oh, thread spawn. How we could do is, okay, thread spawn like this, and then we're going to pass in the function, which would be closure. Dot unwrap. Insert unimplemented. Okay, if I do this, what errors do we get? A lot of errors. Okay, let's take a look. So expected one of that thread equals thread. Oh, I forgot a semicolon. The trait standard standard marker size is not satisfied in Threadpool. Function new returns Threadpool. Standard thread does not have a constant size known at compile time. Up within Threadpool, the trait standard marker sized is not implemented. Oh, okay. So let's see what they end up doing, and we'll move from there. Note, a saying you might hear about languages with strict compilers such as Haskell and Rust is if the code compiles, it works. But this saying is not universally true. Our project compiles, but it does absolutely nothing. If we were building a real, complete project, this would be a good time to start writing unit tests to check that the code compiles and has the behavior we want. Yes, I mean that's the same with tests too, because it's very easy to write tests that don't actually make sure that it's running if the test, like working properly if the test passes. I actually knew somebody who, well, I mean, on a team that I was working on, we would run into like, you know, a front end team was saying like, hey, we're running into this problem. We're like, well, our tests are passing. And it's like, that doesn't necessarily mean that we don't have a problem. It just means we don't know we have a problem. Validating the number of threads in new. We'll continue to get warnings because we aren't doing anything with the parameters to new and execute. Let's implement the bodies of these functions with the behavior we want. To start, let's think about new. Earlier, we chose an unsigned type for the size parameter because a pool with a negative number of threads makes no sense. However, a pool with 0 threads also makes no sense, yet 0 is a perfectly valid U size. We'll add code to check that size is greater than 0 before we return a Threadpool instance, and have the program panic if it receives a 0 by using the assert macro, as shown in listing 2013. Oh, and they're putting the documentation code into here too. Okay, so implement Threadpool. We're now going to assert that size is greater than 0. So this is clearly not working, so I'm just not going to worry about that right second. And we haven't set you up either, so I will just ignore all this right now. Okay, so in Threadpool, public function thread, first we are going to assert that total threads is greater than 0. And if it passes that, then we're going to move on to Threadpool. We've added some documentation for a Threadpool with doc comments. Note that we followed good documentation practices by adding a section that calls out the situations in which our function can panic, as discussed in chapter 14. Try running cargo doc open and clicking the Threadpool struct to see what the generated docs for new look like. So if I write these in here, they're writing it above. So did they put a space? Yeah, so it's create a new thread, a new Threadpool. I mean, because that feels pretty obvious. That's like saying, hey, this is a cat. The size takes in the total. I mean, because like this is all feels like it's fairly obvious. You can do panics, and this one panics when provided number of total threads is less than 1. I wonder if I even need this. I might be able to do that. Let's try. What is the command? It is cargo doc -- open. Let's try running that. So cargo doc -- open. Of course, we can't do that without compiling it first. Okay, so struct Threadpool has no name, no field named max threads. Right, because I sort of changed this and removed that. So we're still going back onto here in an empty one. Okay, so structs Threadpool, we come into here. I mean, so we see the source code of it. So we don't need too many crazy things. Like we know that we're creating a new version of it. So we don't need to say that it's creating a new version. We know that it's taking in total threads, so I don't need to write that in either. But this is good because it's not immediately apparent that it panics when provided number of threads, total threads is less than 1. Okay, so perfect. Instead of adding the assert macro, if we've done here, we could make new return a result, like we did with config new in the IO project in listing 12.9. But we've decided in this case that trying to create a thread pool without any threads should be an unrecoverable error. If you're feeling ambitious, try to write a version of new with the following signature to compare both versions. So public function new, size usize, result, thread pool, and then pool creation error. And that would be like its own type. So we'd create like an enum with errors. Okay, I'm not gonna worry about like doing this right now. We already did like a bunch of these error types in that other project, and then when we do our own, we'll definitely be doing this type. Creating space to store the threads. Now that we have a way to know we have a valid number of threads to store in the pool, we can create those threads and store them in the Threadpool struct before returning it. But how do we store a thread? Let's take another look at the thread spawn signature. So it returns a join handle. So we probably want to just have this be join handles. The spawn function returns a join handle t, where t is the type of the closure returns. Let's try using join handle 2 and see what happens. In our case, the closures we're passing to the thread pool will handle the connection and not return anything. So t will be the unit type. T will be the unit type, empty parentheses. So I wonder, the code listing 2014 will compile but doesn't create any threads yet. We've changed the definition of Threadpool to hold a vector of thread join handle instances, initialized the vector with a capacity of size. Where? I don't see them actually doing that. Set up. Oh, it's in here. I got it now. With capacity of size, set up a for loop that will run some code to create the threads and return a Threadpool instance containing them. Okay, interesting. So our threads is going to be a vector of thread join handle that itself is going to return nothing. Okay, so we can do that. So in Threadpool, this one. Okay, so we're going to have a threads. Threads, this is going to be a type, so it's going to be a vector of type thread join handle. So not thread spawn. Okay, hold on. We need standard thread though in here. Use standard thread before we can do this. Okay, so this allows us to use thread join handle, and then this is just empty parentheses as then we close these up. So no errors, that's a good sign. So then in function new, we need to create this this vector with the number of size of it. So it's going to be let mute threads. So that's just internal to new, okay? Equals vec with capacity size. Okay, so we haven't really done this before, which is create a vector with capacity. So the other thing is, like, we can do this inside a Threadpool here. So in Threadpool, we're also returning threads. And this is going to be a vec. Is it? Yeah, with capacity. With capacity, total threads. And there's not really anything else we need. Oh, so something I noticed for underscore in size, create some threads and store them in the vector. And then we can return Threadpool threads. Okay, so total threads. We probably do want to then take this out here. Let threads equals vector with capacity total thread. So it's an empty vector right now. And then what we want to do is for in 0 dot dot total threads. Now we want to create the threads. Now if we spawn that, is that the best? Because if we spawn it, it wants to like run right away, but we only want to execute when we're done here. So I wonder if I could just do thread new. So can I just do thread? We have spawn, yield now, sleep. Okay, we could use the builder. They're not showing us right now how they're planning on creating these. But of course, we are then returning these threads. We comment that out. We're now returning Threadpool threads. This should kind of sort of be back to working. I did not mean to do that. Cargo run. Failed to resolve. Use of undeclared type for module thread. So thread sleep duration. Oh, that's in main. I totally forgot that we're using thread sleep there, so we can bring this in again. So use standard thread. Yeah, so this is running again. It's still not doing anything with it. Oh, we brought standard thread into scope in a library crate because we're using thread join handle. Wait, where? Oh, thread join handle. Did I do that in mine? I think I did. I did. Using thread join handle as the type of the items in the vector in the thread pool. Once a valid size is received, our thread pool creates a new vector that can hold size items. We haven't used the with capacity function in this book yet, which performs the same task as vec_new, but with an important difference. It pre-allocates space in the vector. Because we know we need to store size elements in a vector, doing this allocation up front is slightly more efficient than using vec_new, which resizes itself as elements are inserted. When you run cargo check again, you'll get a few more warnings, but it should succeed. So yes, we are getting it working now. All right, so what I'm gonna do, because it's 7:53, I don't think I have time to go through all of this and run it before 8 o'clock. So I'm going to start closing down the stream now, and then we'll continue on with this next section with work instruct responsible for setting code from the thread pool next time. And like the code, as always, is going to be up here on Learning Rust, the repo here, and I'll have everything else for that. Let's go ahead and marker